But yeah, today we have an hour, but I'm going to try to offload everything I've learned in 15 years doing industrial and camera architecture to you all, to give you a heads up of what you might run into if you're at a very base level, just trying to grab a lens from the lab and stick it on your imager to get an image and get going right away, to actually designing a whole custom, consumer device system or embedded medical device system, or whatever you're working on. So embedded vision to us at Edmund Optics is across many environments and many industries. So I've worked in medical device, I've worked on some defense applications, I've worked in consumer device, and they're all very different, but they all have a lot of similar challenges. So I'm going to try to stick today to talking about optics and lenses for embedded systems, whether it's going into a machine vision system on a factory robot or into a cell phone or on a drone or autonomous vehicle. There's some commonalities between them and challenges that all these industries face. The great thing about it is as consumer products start to pick up on all these embedded systems, a lot of the hardware and lenses and everything gets cheaper, and there's a lot of information shared between industries as people jump around. So that's been exciting to see. A lot of things that were done 15 years ago in one industry are now being used a lot in another industry. And so the goal of today is mainly to introduce some of the challenges and effects of optics on your final image, and some of the basic theory related to the root cause of some of these issues you'll see in your image or challenges you'll see when matching a lens up to a sensor. And I think most of the people here are image processing people, and I think the reason, if you're not working on the hardware, should still be familiar with the image coming in and why it looks the way it does. You can include all the variations that you might get from your lens in your test data set, if you understand what all these variations might be. And obviously a better image, like a few people have mentioned today, garbage in, garbage out, the better image you have, hopefully the less developing time. The better quality you can get from the lens, the less hopefully pixels you need and everything like that too. So higher processing power and less time processing if you have a good image.